go over this 6th problem together, and then we will see what kind of material we have in chapter 6.3. So if you look at A, again, I purposely give you this thing here just to show you that they can just put all of them together and they generalize it as a factor, right? So you have to know what kind of factor we're dealing with. So if you look at A, and B, hopefully you guys see, or some of you guys already saw that A and B are a little bit different in the sense that in A, we do have a perfect square in terms of 16, but not everything is a perfect square, right? So in A, if you recognize, or hopefully you guys see that this is the only thing that we can do is we can only factor out a GCF, meaning what is the greatest common divider between 24 and 16, and vice versa between x to the 5th and x to the 6th. Basically, what can you extract out? If you guys say 2, that is good. 2 is okay. 2 can go into 24 and 2 can go in 16, right? And x to the 3rd, reminder, if you remember the exponent, we try to take the smallest exponent between the two exponents. But 2 is good. If you guys say 4 is better, but do you agree that A should be the best, right? 8, do you agree that 8 can go to 24 and 8 can go into 16? So when you factor this thing out, reminder that if you have this item, when you factor them out, we need to extract what they have in common. And in this case, they have in common of the 8, because 8 can go to 24, like I mentioned, and x to the 3rd, because x to the 3rd can go into x to the 3rd, and x to the 3rd can go into x to the 5th. Meaning we extract our 8, and as you can see, 8 go to 24 is 3 times, because 3 times 8 is 24. And if I take x to the 3rd out, I still have x to the 2nd. And again, bring down my minus sign, and 8 go to 16 will give me 2 times. I took out x to the 3rd, so there is no longer any x to the 3rd. And in our case, or in my problem, this is all that I can factor out. There's nothing else you can factor out. And reminder, this thing here, you don't need to always have a double the parenthesis, right? So looking at this item here, this is what we, in terms that we have a binomial, but it's not a perfect binomial. What do I mean perfect binomial? Reminder, if you look at B and you say, well, there's nothing can go into 16 and there's nothing can go to 81. I agree with you, right? 16, you have 2, you have 4, you have 8, but 2, 4, and 8 cannot go to 81. And in 81, you have 3 can go 81, 9 can go 81, and basically that's it, right? There is no common divider. And hopefully that you guys remember that this thing here is a perfect binomial, right? And what does it mean by perfect binomial? Because this item here, hopefully you guys see that it's 4x times 4x, and this item right here is 9 times 9, and that is your perfect square binomial. And if we recognize that this is a perfect square binomial and they all separate by a subtraction, and before we on the break, I told you that if you recognize that this is a perfect square and they separate by a subtraction, then all you need to do is put in one of each. In terms of this thing here, 4 times 4 is 16, x times x is x squared, 9 times 9 is 81. So you take each of them and put them in one parenthesis. And what is the difference? One of them is a positive, while the other one is a negative. Again, you put in 4x9 minus 4x9 plus, right? One of them is positive, one of them is negative. Doesn't matter which one you put. You can put 4x minus 9 first, and 4x plus 9 second, doesn't matter. But again, the order of the parenthesis doesn't matter, as long as you can see that this is your perfect square And once you recognize that they are perfect square and they are separate by a subtraction, we call this this is in 6.5, which is a factor binomial in the sense of a perfect square. Okay, so recognize, again, see if you can determine the distinction between A versus B. Okay, and for C and D, well, first of all, question with A or B, and a question with A or B here. Well, if you don't have question with A or B, if you look at C and D, same thing go, which is, we don't need a distinction in terms of this thing here. We just ask ourselves in terms of this item, right? If you remember, this is a trinomial, there's no GCF. So if you remember, what do we do? Well, we ask ourselves, what does the C term? And because the C term is positive, we think in terms of addition, right? Is there two numbers multiplied to give you 64, but add together to give you 16? And hopefully you guys see that all we have to do is break this thing here into two parentheses in terms of an x times an x, that's your x squared. And again, what two number? Hopefully you guys say that this is also a perfect square. 8 times 8 is 64, and 8 plus 8 is 16. And again, what are my sign? They are, because we think in terms of addition, they have to be the same sign. And in this case, they are both positive because the 16, we want it to be positive. And this is the other perfect square item that you have, in the sense that if we have x plus 8 and x plus 8 twice, all they tell you to do is say x plus 8, raise it to the second power. You don't have to write that. You can just write x plus 8 in two different parentheses, and that perfectly fine. Okay, and again, hopefully you guys see, and I purposely, if you look at this thing here and you say, well, wait a minute, Mr. Tran, why D is not 6 times 6? Reminder, 6 times 6 is 36, but 6 plus 6 is not 15. So don't force it, right? Don't force that. The last item is a perfect square, but they need to fit the description that add together to give you the meter term, right? You can recognize that 36 is a perfect square, but if it doesn't fit the description, don't force it to be, right? So in terms of this thing here, let's take a look at D. If you look at D, and again, how do you attack D? And to remind you guys, right? To remind you guys, this is the first thing we're looking at in terms of 36. And 36, because it's a positive number, I'm thinking in terms of addition. And for those of you guys who missed class last time, this is what you guys need to do to factor. Is the first thing is you have to ask yourself, do we add or do we subtract? Secondly, we have to ask ourselves is, what two number? Is there two number multiplied to give you 36, but add together, because it's positive, to give you 15, right? And if you in doubt, right? If you in doubt, let's say I don't know what the number is, let's list this out, right? What do we mean list them out? Well, I know that 1 time 36 is 36. I know that 2 times 18 is 36. I know 3, if I take 3 divided by 36, or 36 divided by 3, I know that 3 times 12 is 36. And some of you guys say, oh, Mr. Trent, right there. But let's just say that we did not see it, right? What does 36 divided by 4? We know that 4 times 9 is 36. 5 cannot go in 36 evenly. And the next number is 6 times 6. Everybody see that the next number is 6 times 6, meaning they are repeated. 6 times 6 is 36. They are repeated, meaning there is no other number. 7 cannot go into 36 evenly. 8 cannot go in 36 evenly. 9 going 36 will give you 4. 11 cannot, 12 going 36 will give you 3, meaning, as I mentioned, if you see something in terms of repeated like this, meaning now there is no other multiple, even or not even, but there's no whole number that can go into 36. Yes, there's some decimal, but there's no whole number that can go into 36. And we're only looking for the whole number, okay? So looking at this item, among this 5 items, is there any two numbers that add together to give me 15? And again, many of you probably say, well, we can stop here, Mr. Tran. We don't have to go 4 times 9 and 6 times 6. But again, let's say we don't know it. Do you agree that 3 times 12 is 36 and 3 plus 12 is 15? And once you recognize that that is your multiple, all you need to do is say x3 and x12. Or x12 and x3, doesn't matter which one, but reminder what are their sign, because we think in terms of addition, they have to have the same sign, and in this case, they are both negative, which is in this item here, we have x minus 3 and x minus 12. And again, looking at this thing here, let me ask you guys here a question in terms of A versus B, or vice versa, C versus D. Any questions so far in terms of this 4 factoring problem? Is all look identical, but again, each of them have a different problem or different criteria that you have to look at. Any questions so far? Well, if you don't have questions, let's take a look at E. And E is just a little bit different in the sense that looking at this item here, so far, if you remember last time I told you guys that if we have some number in front of the x square, or in terms of this thing here, if we don't have an x square, we have to factor something out. We have to somehow make this problem to be something like this, right? To be something in terms of x square plus something or minus something and a constant in the back. We have to somehow make it that way. So in this case, do you agree that I can factor out a GCF? I know that 3 can go into 3, 3 can go in 15, and 3 can go in 18. And also I know that there is a x in all 3 terms, meaning I can take out a 3 and I can take out an x. And if I take out 3 and x, do you agree that I have x squared, right? I don't need to write a 1. And in this case here, we know that this is what we have is minus 5x minus 6. And one thing I want to point out to you guys, ladies and gentlemen, make sure that you know that looking at this thing here, this is our goal, right? Our goal is we get some x squared, and our goal is we have x squared and plus something and minus something, or in this case, this is what we have. And because of the 6 is negative, do you agree that we have to think in terms of subtraction? And is there 2 numbers multiplied to give me 6, but subtract to give me 5? And hopefully you guys say that is 6 times 1 and not 3 times 2. Right? Why do I say not 3 times 2? Again, I agree with you that 3 times 2 is 6, but 3 plus 2 is 5. That's why the sign is make a lot of a difference, right? If this were to be a plus, if it were to be a positive 6, then yes, it's the 3 times the 2. 3 times 2 is 6, 3 plus 2 is 5. But because of this item here is a negative, we have to think in terms of subtraction. And reminder, the bigger number will get the side of the middle term, which is 6 times 5 will give me 6, and 6 minus 1, 6 times 1 to give me 6, and 6 minus 1 to give me 5. And how do I minus, or why do I minus? Because they have to have opposite sign. Negative times a negative will be a positive. In this case, a negative times a positive will be a negative. And because they have opposite sign, we need to subtract and keep the sign of the larger number. And therefore, the larger number will get the sign of the middle term. Okay? And vice versa. Vice versa, if you look at F, same idea go. What do? We can see that we can take out a 2. We can take out a 2, or you need to take out a 2, and you can take out an x to a third, similar to example A. And in this case, we have x squared plus 9x minus 90, right? And this is probably the hardest problem you will encounter. Why is the hardest problem you encounter? Because 90, there are so many multiple, right? Looking at this thing here, first of all, everybody see that the GCF is 2, and basically all I did was I take 2. All I did was I take 2, go into 2, 2 go into 18, and 2 go into this item, right? 2 going to is 1. I don't have to write a 1. 2 going to 18 is 9, and 2 going to 180 is 90. And now this is why is the hardest part is if you look at the 90, and if you in doubt, and this is where a lot of problem, or not problem, a lot of students have problem with is the multiple of a multiple of 90, right? Do you agree that 1 times 90 is 90, 2 times 40, 5, 3 times 30, 4 cannot go into this item here. 4 does not go to 90 evenly. 5 times 16, 6 times 15. 7 cannot go into this number. 8 cannot go into this thing here. 9 times 10. And the next number after 9 will be 10 times 9. And everybody see that if you see the repeated 9 times 10 and 10 times 9, we know that this is the multiple that we have. If none of this thing here fit the description we're looking for, then we say that this is prime. Well, we factor out the GCF already, so it's not really prime, right? So looking at this thing here, what do we need to do? Well, you need to know, do we think in terms of addition or do we think in terms of subtraction? And in this case, because of this, a subtract, not subtract, because in this case is a negative, we think in terms of subtraction. And is that 2 number multiplied to give me 90, which is all of this thing here will give me 90. Is that 2 number multiplied to give me 90, but subtract to give me 9? And hopefully you guys probably say, well, here is the 2 number that multiply to give you 90 and somehow subtract to give you 9, right? 15 minus 6 to give you 9. And if you have that, if that were to be an item, then all we need to do is we say 2x to the third, and we break down my x, and we put 15, and we put 6. Because 15 times 6 to give me 90, and now because they are subtraction, one of them is positive and one of them is negative. Why the 15 is positive? The reason is the bigger number will get the sign of the middle term. So the middle term is positive 9, so the 15 will be positive and the 6 will be negative. And again, this is what we have. This is what we did last time. And ladies and gentlemen, in short, if the reason why I did not mention this earlier in the sense of when we go over this thing here in terms of the try and error, the reason I did not mention that earlier, what you just did for C, D, E, and F, what you just did were try and error. The reason is in this try and error, in front of the x square here, there's only 1. In front of the x squared, there's only 1, and you don't need to mix and match because 1 times 1 is 1, right? And whenever we have something like this, then we say, well, can we take out a 3, right? Whenever we have something like this, whenever it's not a 1, we ask ourselves, well, can we somehow remove the 3? And to remove the 3, we factor out they have to have something in common, right? The same thing go here. Can I take out a 2? And in order for me to take out a 2, I need to have a 2 can go into the 18 and 2 can go to 180, right? So looking at this thing here, this is what we've been doing for last week before the break. Now, what happened in 6.3? What happened if the A term, if you look at this thing here, we still factor this item here. we still factor something in terms of x squared plus bx plus c. But now your A item, your A is not 1, okay? And if you look at this thing here, you say, okay, Mr. Tran, my A item is 2, but I can't, well, we can't, right? We cannot factor out 2. We cannot somehow make this problem to be something like this. We cannot make this problem to be just x squared plus 7x plus 6, because in order for you to take out 2, the 2 have to go into here, the 2 have to go in here, and the 2 have to go in here. And you can see the 2 can go into the 6, but the 2 cannot go into 7 evenly. And if it cannot go into evenly, well, we are stuck with the 2. And everybody see that this problem, this is our new problem. This is our new material or objective. What happened if we stuck with this 2? What happened if we forced to using that? So here come a try and error. And try and error is just like the name. It's basically, again, the reverse FOIL. Reverse FOIL, that's what try and error is. It's basically tell you that you try it out, you try it, and then if you have an error, you try again. So let's take a look at how you were to attack this problem. First of all, for me, this is what I tell you guys is, whenever they ask you to factor, we know that we need to have 2, sorry about this. We know that we have to have 2 parentheses. And if we have 2 parentheses, for this try and error, this is what you want to do is you want to ask yourself, what number can I put it here and multiply to that number? And what number can I put it here and multiply to this number, okay? So one thing we have, or this is what I asked you guys to do is, I wrote a step on the right. I asked you guys to do this item here. First, find the multiple of the A term and the C term, okay? And then you break down your item into 2 parentheses and fill in the multiple of the A term in terms of this item here. The A term will be here. Let me change in color. The A term will be here and here. And the C term will be here and here. Those are your C term, which is you fill in the A term first and you fill in the C term second. And then you have to determine, do you add them together to give you the B term, or do you subtract them to give you the B term, which is when do we add or when do we subtract? If you remember, whatever your C term is, if it's positive, we think in terms of addition. If it's negative, we think in terms of subtraction, okay? And here come, ladies and gentlemen, to make your life a little bit easier, step 5 is the biggest, the one thing to make your life a lot easier is whatever you put in the same parenthesis, they cannot have a common divider, okay? Meaning if you have 2 of the 2, the 2 of 2 cannot fall under or inside the same parenthesis. Okay, so I know it's a first problem, and you look at this step and you say, oh, there's 5 steps. But let's take a look at this thing here. Let's see if I were to do this thing here, or if I were you guys, how would I go about to attack this problem over here? So if you look at this thing here, this is my problem. This is what they tell me to do is find the multiple of the A term. This is my A term. This is my B term, and this is my C term. So do you agree that the multiple of 2 is only 2 times 1 is 2? That's what 2 is, right? 2 times 1. And the multiple of 6, what is the multiple of 6? Let me color code it. The color for red will be my 6. Do you agree that 1 times 6 and 2 times 3? Those are the multiple of 6, meaning those are the 2 numbers that multiply to give me 6. So in terms of this thing here, I cannot get rid of the 2. I am forced to use, or I'm stuck with the 2 in front of my problem. Now, if I'm forced, if I'm stuck, unlike the other problem, right? Unlike this item over here, unlike this item up here, I can get rid of the 2. Unlike this item right here, I can get rid of the 2, I can get rid of the 3. But if I cannot get rid of it, meaning this item I'm stuck, and if I'm stuck, this is what you need to do. Find a multiple. Once you find a multiple, this is what you need to do is break this into 2 parentheses and fill in the A term. And life is good, the A term, you only have 2 times 1. And again, you just fill in the X here for the A term because that you have an X squared. And now your B term, if you remember, let's do the wrong item first. I want to show you that. Let's do the wrong item and then we can do the right item later. Let's say that we're using this multiple 1 and 6. Okay. Can I put the 6 here, ladies and gentlemen? Hopefully you guys say no. Why you cannot put a 6 there? Because step 5 tell me that whatever I put in the same parenthesis, they cannot have a common divider. And again, the 2 and the 6, they have a common divider of the 2. So as long as they are even, as you can see here, we cannot put them together because that's what step 5 tell me to do. Step 5 tell me is as long as whatever you try to put them in one parenthesis, they cannot have a common divider. Okay. So now if we cannot put the 6 there, meaning I have to put the 6 here and the 1 here. And earlier, if you look at this thing here, we know that this item is, both of them is addition because we think in terms of addition. And if you remember earlier, this is what I told you guys to do is take this 2 number and multiply together in terms that you have 1 times 1 is 1. Take this 2 number and multiply together in terms that 2 times 6 will give me 12. And if you add this 2 together, do you agree that this will give me 13? And is that the middle number? Well, the middle number is not 13, right? The middle number is not 13, so I cannot use that. And I know I cannot switch the 6 and the 1 around because the 6 and the 1 is not going to be, it will not work out because they have a common divider. So if I cannot use the 1 and the 6, now I have to use the 3 and the 2. And that's why they say try and error, because if you have an error, you erase it and you try again. Okay. And again, you've been doing this. It's just that last time you did not do the 2 and the 1 because it's just 1. Okay. So if I cannot use the 6 and the 1, I have to use the 3 and the 2. Can I put the 2 here, ladies and gentlemen? Hopefully you say, no, Mr. Tran, the 2 cannot be there. Why? Because the 2 and the 2, they have a common divider. And if they have a common divider, I cannot put the 2 there. I have to put the 3 here and the 2 here, right? Because I cannot put the 2 where my 3 is at because the 2 and the 2, they have a common divider. So in that case, this is what I have. I am forced. I use in this item. So what is 3 times 1? Well, 3 times 1 is 3. And what is 2 times 2? 2 times 2 is 4. And as you can see, if you add this together, that gives us the B term. And this, ladies and gentlemen, is your answer. Your answer is basically, again, let me write it. Your answer is basically 2x plus 3 and then x plus 2. And that is what we do. And why do they call reverse FOIL? Because you fill it in and then you FOIL them out, right? You find the first item, you find the middle item, you find the inner and the outer, right? So this is what we have, which is we don't need to take the 2 times the 1 because the reason how we got those numbers is because we have the multiple of the 2. We don't need to take the 3 times the 2 because the reason why we have that is the multiple of 6, okay? And again, if you're in doubt, you can always FOIL them out, and we did that already. We did that already in that set, okay? So again, looking at this thing here, I know it's the first problem, and you guys a little bit, you know, intimidated. You guys a little bit flusher, right? Like, oh, what to do? How do I start? Well, let's take a look at another one. Let's take a look at another one. And again, I give you the same idea, or not same idea, but I give you the same direction. It's the same instruction, not instruction, but the direction as the same as before. Looking at this thing here, life is a little bit good, ladies and gentlemen. We know we cannot take out a 3, right? We know we cannot take out a 3, so we are forced to use the 3. And do you agree that 3 times 1 is 3, right? What is the multiple of 3? The multiple of 3 is 3 times 1, and that's it. And if you recognize that, then all you need to do is put the 3 here and the 1 here, okay? Now, what is the multiple of 4? What is the multiple of 4? Well, the multiple of 4 is 4 times 1 and 2 times 2, right? So 4 times 1, right? Let me put it in. Let's say, well, let me put a 4 here and the 1 here. That's what your trial and error is. Now, let me ask you guys, what are the signs here? What are the signs? Do we think in terms of addition or do we think in terms of subtraction? And hopefully you guys say that we think in terms of addition because the 4 is positive. And if we think in terms of addition, they have to have the same sign. So both of them will be negative because -4 times -1 will be +4. So now, again, I know you guys say, Mr. Tran, you did it wrong. That's not the right multiple. Well, let's test it out, right? And that's what trial and error is, ladies and gentlemen. This is what they tell you is take a -4 times 1. -4 times 1 will give me -4. Take a -4, not -4. Take a 3 times the 1. 3 times 1 will give me negative. And as you can see, this thing will give me -7. I am not looking for -7. I'm looking for -8. So we know that that does not work out. Now let's try. Well, let's say if we flip this around, right? Let's say if we flip this around, let's say I put the 1 here and the 4 here. Well, do you agree that 4 times 3 is 12? That's too big, right? 4 times 3, this is 12. And if 12 plus something will not give you 8, right? We try to looking for something and the 2 number we put in is too big. So if that were to be the case, if it's too big, we know that we cannot use the 4 and 1. We have crossed our finger that the 2 and the 2 work. If the 2 and 2 does not work, then we say that it's prime, okay? So the 2 and 2 doesn't matter where you put it, right? We know that the 2 and the 3 doesn't have a common divider. So now it doesn't matter which 2 you put first. So now let's test this thing out. What do we have? Well, we know that -2 times 1, -2 times 1, that will give me a -2x. A -2 times 3 will give me a -6x. Well, -6 and -2, do you agree that -6 and -2, that will give me a -8? And ladies and gentlemen, is that the number we're looking for? We got this number. That's our goal. Our goal is we try to find and got that number. -8 is what we're looking for. And if that's what we're looking for, everybody see that this is my multiple, right? All of this preliminary, all of this testing, you don't need it. We know that this is our combination and this is our answer. So again, that's what we have. And the hardest part of this try and error method, the hardest part of this try and error method is you have to try for all the combination. Sometimes, you know, the first one doesn't work, you have the patience, you try another one. Second one doesn't work, you have a patient, you try for another one. And the third one doesn't work, you're like, oh my God, I think it's prime, Mr. Tran, I don't want to try the fourth one, right? One thing is you need to be patient, you need to try it out, all the combination. And this one here, the good thing about this item is The good thing about this item is I give you, the 3 is only, there's only one multiple, okay? But first of all, before we continue, let me ask you guys a question. Let me ask you guys a question on how to start, what to looking for, and how the answer should be. All right, let's take a look at C. Let's take a look at C, and this thing a little bit, a little bit more, not more tedious, well, a little bit tedious, I should say. But the thing is, ladies and gentlemen, I want to emphasize, I cannot emphasize enough that this item right here, number 5, should be the one that save you a lot of time. Okay, this item should save you a lot of time. Make sure that when you put in the parenthesis, the 2 number that you put in cannot have a common divider. Meaning, one thing is, if they are both even number, they cannot be on the same parenthesis. Okay, so let's take a look at this item here, and you can see that this item, what do we have? Well, let's take a look at this item. We know that 4 times 1 and 2 times 2. We know that that is what we have in terms of the multiple of 4. And do you agree that we know that this thing here will be 6 times 1 and 2 times 3? Okay, so looking at this thing here, why do I emphasize that the 2 numbers, as long as they are even, they cannot be in the same parenthesis? If you see that, do you agree that we can eliminate the 2 and the 2? Why can we eliminate the 2 and the 2? Let's take a look at this item here. If you were to use the 2 and 2, where can you put the 6? Can we put a 6 anywhere? Can I put a 6 here, or can I put a 6 here? We cannot put a 6 there, so we cannot use it. And can I put the 2? Can I put a 2 here or the 2 here? Right? Remember, in the parentheses, they cannot have a same common divider, meaning if this is 2 even number, then we can eliminate it because each of this thing here have an even number, right? So in the sense of that, even though they have multiple, you don't have to use all of them, right? So in this case, let me use this thing here. Let me use 4x and the 1x. Let me use that item first, because I know that the 2 should not work out, right? So now, if I use the 4 and the 1, and this is my thought process, I know that I need to fill in the multiple, so that when I multiply the 2 number, I need to subtract to give me the middle term. So if I look up for this item here, can I use the 6 and the 1? Well, clearly we cannot put the 6 here. Hopefully it's clear to you guys that we cannot put the 6 there. The reason is the 4 and the 6, they have a common divider. And if they have a common divider, they cannot be in the same parenthesis. And if they are not, if we cannot put a 6 there, we have to put the 6 here. But if you put the 6 there, you can see that 4 times 6, that's 24, right? And 1 times 1, that's 1. And if we subtract, well, 24 minus 1, that's 5. That's not 5, right? 24 minus 1 would not give me something small like 5. So we know that we cannot use, well, not that we cannot use, but 6 and 1 will not be correct, right? Now, let's attack the 2 and the 3. Hopefully you guys see we cannot put the 2 here. Why we cannot put the 2 there? Because 2 and 4, they have a common divider, ladies and gentlemen. So we cannot put the 2 there. We are forced. We got down to the last combination. And the last combination we have is the 3 got to be here and the 2 got to be there. 3 times 1 is 3. And 4 times 2, that will give me 8. And if I subtract this, I will get 5, right? I have to think in terms of subtraction, and in terms of subtraction, I need to subtract. I got 5, and hopefully you guys see that the phi is positive, meaning the 8 have to be positive and this thing have to be negative. So again, how do I get the A to be positive? Everybody see that in order to be, for the A to be positive, right? In order for the A to be positive, 4 times 2 got to be 8, and 3 times 1 is 3, so the 3 is negative, because when I multiply in order to be negative, one of them have to be positive, the other one have to be a negative. And when I subtract, in order for me to subtract, they have to have an opposite sign. Okay, so in this sense here, if one thing I want to point out is this, ladies and gentlemen, I know I run out a little bit of time. For instance, if you put in the sign first, if you put in this way, if you put in that way, everybody see that this is what our problem will come out to be. Our problem come out to be something like this, which is 3 times 1 is positive and 4 times negative 2 will give you a negative. And if this were to be the case, ladies and gentlemen, if this were to be the case that the only thing that is opposite from your item is the sign, if this were to be the case, hopefully you guys make sure that you don't need to switch the number. Your number is correct. Your number is correct. The only thing that you need to do is you need to switch the sign. Meaning this item have to be positive and this item have to be negative. So again, in the sense of this is what we have. This will be our answer. 4x minus 3 times 1x, or simply just an x plus 2. Okay. And again, I know that this is the first time we saw this kind of problem, and the only thing that I teach you guys is guess it out, right? Plug it out, plug it in, guess it out until you guess it correct, right? So I have a few more problems, and as you can see, we're getting a little bit harder and harder. Looking at this item here, it's a little bit harder in the way that if you look at this thing here, we have 6 times 1, 2 times 3. And this item here, you have 1 times 12, 2 times 6, 3 times 4. Okay, so hopefully you guys see that this item, again, this item, we cannot use it because both of them are even. And if both of them are even, they cannot be together with even number. Okay, so again, let me stop here. Let me stop here with this problem. Let me ask you guys to do this problem, finish this problem, and see if you guys can do your homework. Tomorrow we will continue with this thing here, and we will have, again, I have like a few more problem, and we will do. We will attack a bunch of this problem tomorrow. So let's stop here for today. If you have question, please stay back. If not, if you don't have question,